there are two questions in your assignment, and question 2 we've already solved in class. I'll start with question 1. All right. So question 1 says that the transistor of this circuit, and this is the circuit which is given, this transistor has a beta of 100, and it also says that this kind of a circuit exhibits a VBE of 0.7 volt when collector current of 1 milliampere flows through it. We need to design the circuit so that a current of 2 milliampere should flow through the collector and a VC of plus 5 volt should appear. So at the onset, what do we already know about this circuit? We know that VC should be plus 5 volt, meaning collector terminal voltage should be plus 5 volt. And when a question says design, right? So what you mean is that the parameters that you do not know yet, they're asking you the values of those parameters. In this case, we do not know the value of RE and RC, right? So when the question says design a circuit, they're asking what would be the values of these parameters. So it is already known that VC should be 5 volt. So if I apply KVL on this loop, so if I apply KVL in this loop, what do I get? I write minus 15 plus ICRC plus VC is equal to 0. Correct? And it is also given in the question that we need to make sure that current of 2 milliampere flows. That means IC is equal to 2 milliampere. This tells us that RC should be 10 upon 2 milliampere, which is equal to 5 kilo ohm. So first design parameter we have found. Okay. This was given in the question. Question itself says that design a circuit so that a current of 2 milliampere flows through the collector and a voltage of plus 5 volts appears at the collector. Okay, so we just plugged in the two things, that IC should be 2 milliampere given and VC should be 5 volt given. So just applied KVL in this loop. Okay, this was the first part. Now, how do we find the value of RE? RC is done. Okay. To find RE, we will look at what else is given in the question. So the question says that let me take a quick check of how many of you are there. 52 of you are there. Okay. And I'm assuming that all 52 of you are listening. It is also given that when IC is equal to 1 milliampere, at that time VBE is 0.7 volt. We would always assume that VBE on across this base emitter junction, whenever VBE is on, its value is 0.7. Okay, but in this question, peculiarly it is given that when collector current is 1 milliampere, at that time VBE is equal to 0.7. So it's another way of saying that when IC is equal to 2 milliampere, what would be the value of VBE? Do you remember that the relationship says that IC is equal to IS e to the power VBE by VT. Say for a particular value of collector current and for a particular value of VBE1, this is the relationship. Say I have another value of collector current and another value of base emitter voltage, then this is the value. So essentially, if I say take log on both sides, how could I write this? I could write this as ln IS plus VBE1 by VT. If I subtract equation 2 from equation 1, so I can write it as this should be equal to what? This should be equal to VBE1 minus VBE2 whole upon VT. Okay, so I'm just exploring this exponential relationship, trying to simplify it so that if I have two values of IC given, can we simply drop this value of IS so that we don't need the value of IS to calculate another point in this characteristic. So that is just what we're trying to do here. What we did was we wrote the equation in terms of two collector currents and two VBEs and just took log on both sides, trying to simplify it. This tells us that if given this scenario, suppose it is given that IC1 is 1 milliampere, VBE1 is equal to 0.7 volt, this is known. Then if IC2 is 2 milliamperes, what would be the value of VBE2? If you plug in the values here, you can find that VBE2 would be simply 0.7 plus VT times log of 2 upon 1. And this should give you a value of 0.717 volt. Okay. Why did we find this VBE2? Because our objective is to apply KVL on this loop. Okay. And for us to be able to apply KVL in this loop, we need to first understand what mode is going on, what would be the value of VBE. Then only we will be able to apply KVL here. What you could have also done is that you could have completely skipped through this entire step, okay, all this calculation that we just did, and simply assume that 0.7 and 0.717, it should not make a very gigantic difference in the calculation. However, since this peculiar type of specification was given, we separately found out what would be the VBE value when collector current is 2 milliampere. So suppose this is what we found, right? Now, what mode is the BJT actually operating in? It is already known, that is also given in the question, that VCE is at 5 volt and you can see that the base is grounded, correct? VC is at 5 volt, base is grounded. That means clearly the collector base junction is reverse biased because the circuit, the BJT that is drawn is an NPN BJT, right? So this must be like this. NPN. So if N side, that is collector side, is at 5 volt and base, which is P side, is at 0 volt, that means clearly collector base junction is reverse biased. We can also see that VB is at 0 and the emitter is connected to minus 15. This tells us that clearly the emitter base junction is forward biased. If emitter base junction is forward biased and collector base junction is reverse biased, this tells us that the BJT is in active mode. Understand my objective. I have to find RE. That is what my objective is. So how should I find RE? So since base is at 0 volt and VBE is VB minus VE, this tells us that emitter, this point is at which potential? VE, ये 0 है. So that means VE is at minus 0.717 volt. If you can find this value, and then all you have to do is just calculate the potential drop, or say we have established that active mode is going on. We have also established that VE ki value should be 0.717 volt. If active mode is going on, and it is also given in the question that the beta for this transistor is 100. If transistor is in active mode and beta is 100, and you also know already that IC is 2 milliampere, can you tell me what would be the value of IE?
2.02 milliampere.
2.02 milliampere. IC upon alpha. Alpha की value होती है beta upon beta plus 1. If I apply KVL in this loop, it would mean, and let me draw it like it would be drawn in a circuit. So this means this is the scene. So this tells us that 15 minus IERE, right, plus VE, yani minus 0.717 should be equal to 0. This implies that. So can you tell me what would be the value of RE that you will get?
7.07 kilo ohm.
Right? So we found both the parameters that were unknown. So this was a design question where situation was given to you and you had to find what is the value of design parameters, circuit parameters. Any question here? Yes.
Means that the equation which you have used, the current and voltage.
Which equation?
Current and voltage, like we have changed 1 milliampere to 2 milliampere. For a small change of current, we neglect sigma.
Yes, so in this particular question, they had specifically said that VB 0.7 when collector current is 1 milliampere. So now solve the question so that collector current is 2 milliampere. That is why we use this relationship and solve that entire thing. But in general, you could have, that's what I was saying earlier, that you could have completely skipped this entire part and you could have simply assumed that VBE on is 0.7 volt. That would have been absolutely correct. Okay. This is just a little more refined answer, but in that case, you would have written that VE is equal to 0.7 volt, and you would have done the exact same thing. Whenever you know that active mode is going on, you can always assume that VBE on is 0.7 volt and just solve the entire question. And that is what we will do in the next example. RC is given to be 1 kilo ohm. This is connected to a supply voltage of 10 volt. There is a base resistor of 10 kilo ohm and this is connected to some VBB. Okay, this is a circuit that is given. Question is, find the value of VBB such that the BJT is in active mode and VCE is 5 volt. Means for 3 different scenarios, you have to find 3 different VBB. So first scenario is that if it is given that the transistor is in active mode and VCE is 5 volt, then what would be VBB? The second case is find VBB if the BJT is at edge of saturation. And the third case is find VBB if the BJT is deep in saturation. And ऐसे condition में when it is deep in saturation, the value of beta forced is also known to you and that is 10. And the general beta of this transistor is known to be 50. It's obvious that when the question says that beta is equal to 50, that means the ratio of collector current to base current in active mode is 50. That is what is given. So let us take up these 3 cases one by one. So understand that the question is very, very simple and very direct. It is just asking you what should be the value of VBB so that the transistor is driven into a particular mode. So the first part is what should be the value of VBB so that the transistor is in active mode. So the process, the approach should be the same, and the approach is very simple. Given that a particular mode is going on, you can always find the value of IC. If you calculate the value of IC, from there you can land on the value of IB, and from there you can simply apply KVL in this loop and you can land at VBB, right? So given the first case, VCE is 5 volt. So can you tell me how you'll find IC? You will simply apply KVL in this loop. Apply KVL here. This is IC. So I can write minus 10 plus ICRC plus VCE is equal to 0. I know RC, I also know VCE. That gives me IC 5 milliampere. Correct. It is known that active mode is going on. That means you know that the relationship between IC and IB is that IC is equal to beta IB, right? That means IB will be equal to IC upon beta. That means 5 upon 50, which is equal to 0.1 milliampere. If IB is known, then all you have to do is apply KVL in this loop, right? So that should give you minus VBB plus IB RB plus, because active mode is going on, this junction is on, and like I've said before, we can always assume for mathematical simplicity that the value of VBE when this junction is on is 0.7. This should be equal to 0. This tells us that VBE should be IBRB plus 0.7. This tells us that VBB, its value will come out to be 1.7 volt. Okay, so this is the answer for the first part, where it says that if active mode was going on and VCE was 5 volt, then what should be the value of VBB? Understand the procedure is very simple in all cases. Because you have to find VBB, eventually you need to apply KVL in this loop, in the base emitter loop, right? And for you to be able to apply KVL here, you need the value of IB. And to find the value of IB, you need the value of IC or some other condition which should be mentioned in the question. The second part says that you have to find VBB at the edge of saturation. Okay, what does this mean? Edge of saturation. When the BJT is at edge of saturation, you can say that VCE is 0.3 volt. Okay, this BJT being at edge of saturation is a fancy way of saying that VCE is 0.3 volt. Use the same procedure and quickly calculate and tell me what should be the value of IC. As a result, what should be the value of IB, and consequently, what should be the value of VBB. IC should be 9.7 milliampere because VCC minus VCE upon RC. So 10 minus 0.3, VCE is 0.3 upon RC 1K. So this should give you 9.7 milliampere. But to find the value of IB, you need to know which mode it is going on, right? So when it is at edge of saturation, but it has not gone deep into saturation, the relationship between IC and IB is still related with beta, meaning even at edge of saturation, it is safe to assume that IC by IB is equal to beta. Okay, you cannot assume this when it is deep in saturation, but since this is just the edge of saturation, you can always make this assumption. And having known this, you can say that IB will then be 9.7 milliampere by 50. This is what beta is known to be. That gives us 0.194 milliampere as the value of IB. And as a result, VBB, again applying KVL here, minus VB plus IB RB plus VBE on is equal to 0, implies VBB is equal to IB plus VBE on. So this should give me what? Can you tell me the value? What would be the value of VBB? 2.64 volt. Correct. Okay. That was the second part where it was given that you have to find VBB if the BJT is at edge of saturation. Okay. Now coming to the third part. The third part says that if the BJT is deep in saturation, what should be the value of VBB that drives this BJT deep into saturation? So if BJT is deep into saturation, for mathematical simplicity, you can assume that VCE is equal to zero point 0.1 volt when BJT is deep in saturation. Okay. And now that VCE is 0.1 volt, tell me these values. Understand that deep in saturation, the collector current and base current, they are no longer related by beta. Okay. And when in saturation, when deep in saturation, the ratio of collector current to base current is called beta forced. And it is given that if beta forced for this case was known to be 10, understand that beta was 50, right? This is the relationship between collector current and base current when in active mode. And we know that beta forced will be much, much less than actual beta. So actual beta is 50, but beta forced is 10, which is given in this question. So knowing that, please quickly tell me what would be the value of collector current, base current, and VBB. The book also says that you can assume this to be 0.2 volt, but I'm okay with you assuming it to be 0.1 volt or 0.2 volt, but whatever you assume, you should state it. Okay? Whatever you assume to be the VCE sat value, meaning when BJT is driven to saturation, what should be the value of VCE? That value, whether you assume it to be 0.1 or 0.2, or you assume it to be 0.15, or whatever you assume it to be, you should write it. Okay. And you have to ensure that that value, this VCE sat value, should be less than 0.3 volt, because 0.3 volt is what happens when it is at the edge of saturation. I would recommend you take something like this. Anything less than 0.2 volt, whatever you take, you write that value, calculate the value of collector current. So suppose you assumed it to be zero point 0.1 or zero point 0.2, what would be the value of IC?
9.9 milliampere.
9.9 milliampere is what you get if you assumed 0.1 volt, right?
Yes, ma'am.
And if you assumed 0.2 volt,
9.8.
9.8. Consequently, what would be the value of IB? It will be IC upon beta forced.
0.99 and 0.98.
So 0.99 or 0.9898. So I'm doing both of them because I'm going with both of these assumptions, but you can select any one. So if I go ahead with 0.2, this is where I land. And what would be the value of VBB?
10.5.
10.5 volt. So this solves your third part of the question. So this is something that you should keep in mind. Any questions? All right. So I'll give you 2 minutes to just think of if you have any questions, if you would like to ask the question, or you would like to ask the question after the class, or you would like to post it on chat. Think about it, and we'll experiment with WebEx soon. All right, thank you so much. Web of us is the value of VBE always 0.7. The value of VBE can be taken as 0.7 only when you know that that junction is on. I understand that the previous question might have thrown you off a little bit because I made you calculate the value of VBE again. Okay, but that was just to demonstrate the junction characteristics, the nature of that being a PN junction. Only in forward biased. When emitter based junction is reverse biased, that time that junction will be open, right? So no current will flow through it. So you will not be able to apply KVL in that loop then. If the situation is that cutoff mode is going on. So emitter based junction is reverse biased. We cannot assume that its value is 0 volt in cutoff mode, because 0 volt would mean that it is short circuited.